All right, calculus, here we are. We're going to try to make a video in this fashion using YouTube Live and this setup here. I actually think we've got a shot at this. We'll see how it goes. Anyway, folks, what I have here is your review unit, page 10 paper. This is in your review unit packets for fall 2020. This is page 10B. Sorry, page 10B. Find the domain of those two functions right there. This is being made before. Now, I know there's going to be some issues maybe with the screen. You're going to see something here. Anyway, it should be all right. We're doing the best we can, trying out many different models here. All right, I'm going to do the best I can to help us out and make better videos than just me writing something down or just showing you what I've already written down. Anyway, here we go. We have, you don't need to necessarily know this by now, you should, if you're watching this in late August, that is a half circle, radius 5, half circle, radius 7. If you didn't know that, we have a square root function. You can take the square root of 0. So I need to set what is inside the square root equal to 0. Then I get x is plus or minus 5. So there's going to be some sort of boundary points. X equals plus or minus 5. So that looks good there. All right. So something's happening. Let's look. Can I plug numbers that are smaller than -5, larger than -5, or in between? Well, let's plug -6 in. You plug -6 in for x, you get 25 minus 36, which is the square root of -11. No bueno. If I plug in +6, I get 25 minus 36, which is the square root of -11. No bueno. If I plug in 0, I get the square root of 25, which is 5. So I can have any number from -5 to 5, including both, because I can take the square root of 0. My domain would be -5 to 5. I use brackets to show -5 and 5 are included in my domain. Same deal here for number 2. Let's switch the colors for us. Set, ooh, maybe it's the same deal, so be careful. So I lied, this is not. This is the half circle there. We got to be careful on this next one. What is this next one going to be? This one is the half circle that we will talk about. So we're right here. All right, so I set what's inside the square root equals 0. I get plus or minus 7 again. This time, though, if I plug 0, which is in the middle of -7 and 7, if I plug 0 in for x, I'm going to get the square root of -49, which is imaginary. If I plug 8 in for x, get 64 minus 49, which is the square root of a positive 15. That's good. If I plug -8 in for x, I get the square root of 64 minus 49, which is the square root of 15, and that's also good. So the domain here would be any number from -infinity to -7, including -7, union any number 7 or more. So it is not the in between both numbers like it was on one. And look at it. -x squared, +x squared. It kind of makes sense that it is like that. They are different. Okay, so those are the two different types when we're dealing with square root functions we might see early on here. All right, so there we go. The first one, let's take a look here. Simplify each expression. All right, so by now this is not supposed to be the first video with this. We know that cos inverse. If you type in cos inverse of -3/7, make sure you're in degree form, you're going to get an angle that is bigger than 90 degrees. Okay, an angle that is bigger than 90 degrees. Let's see if I can get my calculator on and working quick enough. I am in degree mode here. So I do cos inverse, -3 divided by 7, and I get 100, and I hope you can see that, like 115.4 degrees. All right, so it's the second quadrant. Cos inverse, when it's negative, you get angle there in the second quadrant. So I'm going to draw a triangle in the second quadrant that has a cosine ratio of -3/7. And I want to figure out what is sine of theta. Sine of theta is, I'm going to do the Pythagorean theorem, y. -3 squared plus y squared is 7 squared. 9 plus y squared is 49. Y squared is 40. Take the square root of 40. It's 2 root 10. It is positive. It is positive because y is positive in the second quadrant. So 2 root 10/7 sine theta. All right. Tan inverse of -2/5. Type in tan inverse -2/5. You're going to get an angle that is negative between 0 and -90. I guess between -90 and 0. Okay, tan inverse, when it's negative, you're going to get angles in the fourth quadrant there, just like sine. So opposites and adjacent. Now y is negative, so there we go. So here is theta. I want to know what cosine theta is. What is cosine theta? If theta is a tan ratio of -2/5. Okay, Pythagorean theorem here, 5 squared plus a -2 squared is equal to r squared, 25 plus 4. Get in the habit of showing a bunch of your work in your homework. Here, we get the radius is the square root of 29. So, cosine of theta is adjacent over hypotenuse. Multiply top and bottom by root 29. You're going to get 5 root 29 over 29. Nice thing about those TI-30XS's that I'm showing you right here is that they will do, if you type in 5 divided by the square root, you got to make sure you're in the right mode. Make sure you don't type something in wrong. Goodness gracious. 5 divided by square root 29. You get 5 root 29 divided by 29. These calculators are the best for you right now. All right, let's take a look at these next two here. On the page, sine inverse -4/9. Type in sine -4/9, and what do you get? An angle between -90 and 0. Fourth quadrants there, because negative angles. If you just add 360 to them, then you get, again, it's coterminal, then you get something between 270 and 360. So here is theta. Theta has a sine ratio of -4/9. The radius is always positive, so that 4 is negative. We're going to call this x. I want to know what tan theta is. If theta has a sine ratio of -4/9, quadratic, not quadratic, Pythagorean theorem time. X squared plus 16 is equal to 81. X squared is 65. X is the square root of 65. It is, in fact, positive because you're going to the right on the x-axis. So tan theta is a -4 over root 65. Multiply the top and bottom by root 65. It's not the most pleasant looking answer, but that's what we got. -4 root 65 over 65. Then to finish off this page, got a sine ratio of 3/5. Sine inverse of 3/5 is going to give you an angle in the first quadrant. Okay, so 3/5 is great too. So opposites, hypotenuse. Folks, it's a 3, 4, 5 triangle. Know those Pythagorean triples. So once I know what secant theta is, well, here's the thing. I know that cosine is adjacent over hypotenuse, so I know that secant is the reciprocal of cosine. That one was nice and easy. All right, folks, going to see how this goes. Hopefully the next ones get better, but this is Yak Math Videos signing out.